Hi, I'm Matt, and in this video we're going to talk about the derivative of the sine and cosine function. So first off, let's talk a little bit about the derivative of sine of x and cosine of x. And one very interesting property we're going to say of these derivatives is that they're cyclic. This is what I mean by that. So let's imagine we start with the function sine of x and we take the derivative of it, or d dx. We're going to say that we get the cosine function. And then if we take the derivative now of cosine, or d dx of cosine of x, we're now going to get negative sine of x. If we take the derivative again, we're going to get negative cosine of x. But most interestingly is that when we now take the derivative of negative cosine of x, we get back to sine of x. So these four functions, their derivatives are going to go in this cycle, where we see that again, sine goes to cosine goes to negative sine, and negative sine goes to negative cosine, and then the cycle repeats itself. So now let's write this a little bit more clearly and talk about what happens when we have more than just an x inside the trig function, but instead a function g of x. So if the trig function acts on a function g of x, so for example, if we had sine of g of x, the result from the previous slide is just going to be multiplied by g prime of x. So more clearly, if we take the derivative of sine of g of x, we're going to get cosine of g of x times g prime of x. So again, our sine becomes a cosine. We keep the argument inside the trig function the same, and then we multiply by the derivative of what's inside the trig function. We do the same thing for cosine. If we have cosine of g of x, we say that the derivative of cosine is going to be negative sine, and keep what's in the parentheses the same, and then we're going to multiply by g prime of x. Now from here, I do want to bring up the other two rules, which are the derivative of negative sine and the derivative of negative cosine of g of x. And we see that they follow the same pattern above, because the derivative of negative sine is negative cosine, and then at the end we multiply by g prime of x, and likewise for negative cosine. However, if you're thinking to yourself that there feels like there's a lot of rules to memorize, you really only need to memorize the first two. Because, for example, looking at the second one, if we have the derivative of negative cosine, we could keep the negative and then take the derivative of cosine is negative sine, and then notice that the two negatives would make a positive. So we could really get these two blue rules just by using the green rules up top. But if you prefer to memorize all four, that could be helpful too. That's up to what works best for you. So now let's look at some examples. So we're going to take the derivative first of f of x is equal to negative sine 11x. So here we're going to use the third rule down on the previous slide, which is our rule for d dx of negative sine of g of x. So first off, I'm going to write that rule. So d dx of negative sine of g of x, we said was going to be equal to negative cosine of g of x times g prime of x. So now the first thing I'm going to want to do before I plug into this rule is identify what g of x is and then use that to find g prime of x. So g of x, we say, is whatever is the inside of the sine function. So here we find that g of x is equal to 11x, because again, that's what's inside the sine function. And from here, we're now going to need g prime of x, so our derivative of what's inside the sine function. And to do that, we're going to use power rule, and that says that the derivative of 11x is just going to be 11. Now that we have that, we could plug into our rules for derivatives. So we find that our derivative here, or d dx of negative sine of 11x, is going to be equal to negative cosine of 11x times g prime of x, or times 11. So this is essentially our final answer. We're just now going to want to write it a little neatly. So we're going to write now that f prime of x is equal to a negative 11, where we brought our coefficient at the end to the front, times cosine of 11x. So again, f prime of x is negative 11 cosine of 11x. And that will be our final answer. For our second example, we're going to have f of x is equal to cosine of 3x squared minus x. So the first thing I'm going to do is, since we have a cosine function, I'm going to write our rule for cosine, which says that d dx of cosine of g of x is going to be equal to negative sine of g of x times g prime of x. So again, the first thing we're going to need to do is identify what g of x actually is. G of x is going to be whatever inside our trig function. So here, g of x we find is 3x squared minus x. And now we also need g prime of x. So we're going to use power rule to differentiate g of x. Using power rule, the derivative of 3x squared is going to be 6x, and the derivative of x is going to be 1. So we get that g prime of x is 6x minus 1. So now we need to plug into our rule. So we have d dx of cosine of 3x squared minus x is going to be equal to negative sine of 3x squared minus x times 6x minus 1. And from here, that's all we have to do. We now just need to write our solution neatly. And we get f prime of x is equal to negative, I'm going to move our binomial term to the front, so negative 6x minus 1, with the 6x minus 1 in parentheses, times the sine of 3x squared minus x. And that is our final answer. For our final example, we're going to be taking the derivative of the sine of the negative cosine of 4x. So at first this seems very complicated, but we really can do it with the rules we've already gone over. Just instead of our g of x function, or our inside function for the sine function, being a polynomial, here it's just going to be another trig function. But again, all the same rules apply. And when we have what I'm going to call nested trig functions, we're always going to start with the outside function. So that would be our sine of x here. So to start out, I'm going to write the derivative rule for sine of x. And that's that the derivative of sine of g of x is going to be equal to cosine of g of x, and then multiplied by g prime of x. So we're going to want to first identify g of x, and that's what's inside our sine function. So we're going to find that g of x is negative cosine of 4 of x. However, when we go to find g prime of x, we see that's a slightly more complicated than a polynomial, because instead of being able to use power rule, we're going to need to use another trig derivative. So we're going to find that g prime of x is going to be the derivative, or d dx, of negative cosine of 4x. So now we need to find what the derivative of the negative cosine of 4x is. And to do that, I'm going to write our derivative rule for negative cosine. And that's that the derivative of negative cosine, or d dx of negative cosine of h of x, I'm using h of x instead of g of x here just to avoid confusion amongst the two different parts. And that the derivative of negative cosine of h of x is going to be positive sine of h of x times h prime of x. So again, we now need to identify the inside part of the cosine function. And here, since it's negative cosine of 4x, h of x is just going to be 4x. And using power rule, we find that h prime of x is going to be equal to 4. So now that we have h of x and h prime of x, we could plug into the above function, or the above rule right here. And that says that d dx of negative cosine of 4x is going to be equal to sine of 4x times 4. Again, just plugging in 4 for h prime of x and plugging in 4x for h of x. But now this derivative of negative cosine of 4x is exactly what we needed to find for our upper part. So now we could go back to g prime of x. Since we found that the derivative of negative cosine of 4x is 4 sine 4x, we now have effectively found g prime of x. So now that we have g prime of x and g of x, we could plug back into our first trig rule we wrote. And that says that d dx of sine of g of x, or in this case, d dx of sine of negative cosine of 4x, is going to be equal to cosine of g of x, or cosine of negative cosine of 4x, and then multiplied by g prime of x, or 4 sine 4x. The last thing to do is just going to be to write this up neatly, as f prime of x is going to be equal to 4 sine of 4x multiplied by the cosine of negative cosine of 4x. And that is our final answer. However, we could do this problem another way, and in some ways the other way may be a little bit simpler for some people. So we're going to now go through how to do this problem with the chain rule. So remember that the chain rule is used for nested functions, and the chain rule says that d dx of g of h of x is going to be equal to g prime of h of x now times h prime of x. And so when we have chain rule, we need to figure out what our outside function g of x is and what our inside function h of x is. So h of x, or our inside function, is usually going to be written in parentheses, as another function will be acting on it. And looking at that, we can see that negative cosine of 4x is going to be our inside function, because it is being acted upon by the sine function. So again, if negative cosine of 4x is our inside function, that means our outside function will be the sine function. So g of x is going to be sine of x, because again, sine is the function acting on the negative cosine, and our inside function h of x is going to be equal to negative cosine of 4x, as that's the function being acted upon. From here, we're going to want to find g prime of x and h prime of x. From the first slide in this presentation, we found that g prime of x is going to be cosine of x. And then we need h prime of x, which would be the derivative of negative cosine of 4x. Typically, if we were starting with chain rule, we would need to work this out from scratch, but we've already done the derivative of negative cosine of 4x on the left side, and we found that the derivative of negative cosine of 4x was 4 sine 4x. So I'm just going to take that result and reproduce it over here by writing h prime of x is 4 sine of 4x. Now that we have g prime of x and h prime of x, we need to find our two pieces that go in the chain rule. So the first is g prime of h of x. So we're going to plug h of x into our derivative function g prime of x. And this gives us that g prime of h of x. In this case, we're going to want to find g prime of negative cosine of 4x. So we're going to plug in negative cosine of 4x to g prime of x, and that's going to give us cosine, as cosine was our g prime function, and that's going to be cosine of negative cosine of 4x. And then we're also going to want to find h prime of x, but we already did that. So now we already have our two pieces we need. So plugging into chain rule will give us that d dx, or f prime of x, is going to be equal to g prime of h of x, or a cosine negative cosine of 4x. And then we're going to have h prime of x, or times 4 sine 4x. And we see that this method gave us the same answer as our other method. However, we got there in slightly different ways. Both methods are equally valid for solving this problem, and which way you choose to use going forward is up to you. So now, here are 4 examples for you to try on your own. The first is the derivative of sine of x squared minus 4x plus 3. Problem 2 is negative cosine of x cubed. Problem 3 is negative sine of 1 divided by x. And problem 4 is another example like the final one with nested trig functions of cosine of x squared. Now, the solutions to these problems will appear in 5 seconds. Okay, so for the first question, you should have gotten cosine of x squared minus 4x plus 3 times 2x minus 4. For problem 2, you should have gotten sine of x cubed times 3x squared. For problem 3, you should have gotten cosine of 1 divided by x times 1 divided by x squared. And then for problem 4, you should have gotten sine of cosine of x squared times sine of x squared times 2x. Now note that in problem 3 and 4, you may have gotten negative. If you had a negative in your answer that's not supposed to be there, watch out for negatives canceling. Because in both question 3 and 4, you end up with the product of two negatives that makes a positives. I hope you got these. If not, feel free to leave any comments you have about this video or derivatives in general in the comments below. Thank you so much for watching. Have a great day.